Today we're going to talk about the converse of the Pythagorean theorem. Now, to understand the converse of the Pythagorean theorem, you have to understand what the Pythagorean theorem is. The Pythagorean theorem states that a squared plus b squared equals c squared if it is a right triangle, where a and b are the legs of a triangle and c is the hypotenuse of a triangle. But it only works if it is a right triangle. The converse to the Pythagorean theorem states that if a squared plus b squared equals c squared, then we know it's a right triangle. Then the triangle is a right triangle. This is a theorem we use to find out whether or not triangles are right triangles. Let me show you a couple examples. In this case, we want to verify that these two triangles are right triangles. So we're going to start by using the Pythagorean theorem, which is a squared plus b squared equals c squared. Now what I'm going to do is label my sides quickly. This is my a, my b, and my c. Now I'm going to be using a calculator to do a lot of these calculations. You will not be able to see it on screen, but you'll probably hear it as I type it in. Now I'm going to go ahead and substitute my numbers in for my variables. So we're going to have 9 squared plus 15 squared equals 3 times the square root of 34 squared. Now 9 squared is 81. 15 squared is 225. And 3 times the square root of 34 squared equals 306. Now 81 plus 225 is 306. So 306 does equal 306. So now we know that this is a right triangle. We verified it by using the converse to the Pythagorean theorem. Let's go ahead and work on the next one. On this one, I'm going to go ahead and label my sides. Again, your hypotenuse is always going to be your largest side. So we have A, B, and C. So I'm going to substitute that into the Pythagorean theorem, and we get 22 squared plus 14 squared equals 26 squared. Now 22 squared is 484. 14 squared is 196. And 26 squared is 676. Now 484 plus 196 equals 680, which is actually larger than 676. So they did not equal. So that tells me that this triangle is not a right triangle because they did not equal. It was greater than. Okay? Here's some other examples. And this one, it wants us to tell whether a triangle with the given side lengths are right triangles. Okay? I'm always going to label my sides. I think it makes it easier. I'm going to start with my largest. I know it's my hypotenuse. So 8 is my C. And then we're going to go my A and B that way. Again, we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. And we're going to plug our numbers in. And so we're going to get 4 squared plus 4 times the square root of 3 squared equals 8 squared. Now 4 squared is 16. 4 times the square root of 3 squared equals 48. And 8 squared equals 64. 16 plus 48 does equal 64. So 64 equals 64, so this is a right triangle. Okay? So I would write right triangle. So we know that that is a right triangle. Let's go ahead and work on the next one. I'm going to label my sides again, A, B, and C. Again, C is 14, which is the largest, so it's my hypotenuse. I'm going to plug in the numbers. We get 10 squared plus 11 squared equal 14 squared. 10 squared is 100. 11 squared is 121. 14 squared is 196. 100 plus 121 is 221, which is greater than 196. So this is not a right triangle. One neat thing is if you find out they are not right triangles, you can find out whether or not they are a acute triangle or an obtuse triangle. If the square of the hypotenuse, or the longest side, or C, is less than, so C squared is less than the square of the other two sides, so A squared plus B squared. Oh, come on, work. Then you know that it is an acute triangle. So again, if the square of the hypotenuse is less than the square of the other two sides combined, then you know it's an acute triangle. And the opposite, if the square of the longest side or the hypotenuse is larger than the combined value of the squared of both sides. Oh, let me erase that real quickly. Make it better. So if it's larger than A squared plus B squared, then you know that it is an obtuse triangle. So again, if C squared is greater than A squared plus B squared, it is an obtuse triangle. Let's look at an example of this really quickly. First it's asked, can the segments with the lengths of 4.3 feet, 5.2 feet, and 6.1 feet form a triangle? Let's do that part real fast. Now remember, if you combine the smaller two, if you add them together, and the number we're going to get is 9.5, and your third side, 6.1, is less than that number, then it can be a triangle. So yes, this can be a triangle. Then, yeah, we know it's a triangle. So then it wants us, so it says, if so, would the triangle be acute, right, or obtuse? To do that, we're going to have to use the converse of Pythagorean's theorem. So, A squared plus B squared equals C squared. Okay. We're going to go ahead and plug our numbers. Well, I'm going to label it. We have A up here, B on this one, if my stylus will work, and C. We're going to plug these numbers in, and we get 4.3 squared plus 5.2 squared equals 6.1 squared. Now, 4.3 squared is 18.49 plus 5.2 squared is 27.04 equals 6.1 squared, which is 37.21. Now if we combine 27.04 and 18.49, we get 45.53, which is larger than the square of our hypotenuse, which is 37.21. So if the hypotenuse is less than the other two sides combined, if we go back to our other page, if it is less than, we know that it is an acute triangle. Okay, because it's less than, we know it's an acute triangle. So we'll come back to our side, and since it's less than, our C is less than, we know this is an acute triangle. And that's